I didn't participate in game jams for quite a while. I was hoping to find some time to participate in the 7 days roguelike challenge this year, but unfortunately I couldn't make it. However, I still decided to use the theme of roguelikes to practice Rust and programming in general. I wanted to recreate a dungeon generation method I've used in some of my previous experiments. The algorithm is pretty simple. Assuming this grid is our game world, let's choose one column close to the middle with some randomness. This column will be a divider. Now we want to subdivide the resulting two partitions further, but let's add one column buffer from either side of the divider. Later you will see why. Now I can do the subdivision, but this time we will choose rows as dividers. And we also want to add buffer rows here as well. And now we can continue the subdivision of the resulting 4 partitions. So basically it's recursion. At some level of this recursion, we want to use the area of the partition to create a room instead of subdividing it. For example, I will just stop subdividing after the 3rd level of recursion. We can randomize the size of each room a little bit within the available space. Choose one cell on the closest side to the last split for each room. At this point, the recursion starts to unwind, and on the way back we can connect the resulting partitions or rooms with corridors. First, we will connect the rooms by filling the cells from the doors to the nearest split in a line, and then filling the cells on the split itself. After that, let's pick a cell on the split between the corridors leading to the rooms. We will use these cells to connect the adjacent partitions using exactly the same method as we did with the rooms. And let's just keep on doing it until the recursion is completely unwound. And this is basically it. Now let me quickly show you the code I've written to implement this. Quick reminder, I am still very new to Rust, so it is most certainly not the best example of Rust code. I am sure I will be embarrassed by it in a month from now, but I still want to share it. I think this problem demonstrates the beauty of recursion pretty well. The result is a seemingly complex structure, but in order to achieve it, we only need to perform a few simple actions, and the recursion does all the magic. Let's have a look at the print division function. Calling it will print the resulting dungeon in the terminal passed is the first argument. Split parameter tells the function the way the given partition should be split. It can be either vertical or horizontal. The next 4 parameters define the partition's location and size within the grid. And the last level parameter is used to keep track of the current level of recursion. In my implementation, I am using it to determine if it is the time to stop splitting the partition and create a room instead. If the level value reaches a specific constant, I use the given size of the partition to generate a slightly randomized rectangle within it and print it to the terminal. The result of the function is the location of the door to the room. Depending on the way the parent partition was split, the door can be located on one of 4 sides of the room. The door should always face the other room created from one partition. If the room level is not reached yet, the function will go ahead and split the given partition in 2. To split the partition, we need to pick a column or a row to split and then call the same print division function on the resulting partitions. Remember that print division function returns the position of the door to the resulting partition or room. We called this function twice for 2 partitions, and now we have 2 positions of the doors, and we want to connect these doors with a corridor. Print corridor will just print a block character at every cell where the corridor should be. And again, print division must return a position of a door, or generally speaking, the position where the corridor must lead. For a partition, we return the position on the split between the doors of its children. Recursion. I don't particularly like the code I have here, as these 2 match cases look very similar to each other. The only difference is that one is vertical and other one is horizontal. Maybe you can come up with a better code. And that's it. I will share the link to the code in the description. I'll see you in the next video. Thank you for watching. Bye.